Hello there. Welcome to Streaming Frontiers. Today is Wednesday, March 25th. I'm Viktor Gamov of Confluent, and I will be your captain in this journey where no data streaming engineer has gone before. I'm extremely excited that I'm back live because we got some break because there was a lot of thing going on. There was obviously the end of year, holidays, lots of travel happened. So and now we're back. And today we have like a very special episode. I have like a very special guest today with me. And before we start, so let's see what is happening here. What is happening in the world if people hear and they can see us. I see there's at least few people live in my monitoring screen. Hopefully, let's make some noise in the comments. If you can see us, you can hear us. The audio is fine, video is fine. Hopefully, audio and video is fine because we have a very packed, very packed the agenda for you today. I'm trying to see and make sure that everything is working. So that's why your comments will definitely help. So, Streaming Frontiers, this is the show where I'm talking about different technologies that somehow involved with data streaming. And a lot of technologies involved around what things do we do here at Confluent. So today we're going to be doing like a big surprise for the audience that we usually don't talk much. So platform engineers and people who are actually maintaining some of the Kafka infrastructure. All right, so let's see if my comments actually working. Okay, so LinkedIn user says all good. Great, this is great to hear that it's all good. We do have Jen Wheeler. Great to see you here. Thank you so much for coming. Write down, let's do this. Write down in the comments if you are on the LinkedIn or in the YouTube. I see if you are LinkedIn and YouTube. But if you write where you're coming from, I'm coming to you live from East Coast, from New Jersey. It's my third New Jersey studio, how I like to call it. Now, quick housekeeping items. So first of all, you're watching this, hopefully you're watching this on Confluent Developer YouTube channel. Confluent Developer YouTube channel, you can find a bunch of different the materials and to learn about data streaming. Looks like we're live here. Let's see if it actually works. Hopefully I will. Oh, okay, it works. I'm not going to be watching myself live on this. Also, we do have a Confluent Developer podcast. If you didn't sign up for this, please do. Confluent Developer podcast. This is where we bring in very interesting people from the industry and interviewing them about their challenges, implementing data streaming, or maybe successes. Also, look at this guy. Look at this guy. He just like unstoppable. He doing a bunch of videos about A2A protocol in skills and MCP. Table flow in real-time data, what he's talking about. Specifically, we just released on the developer.confluent.io, we just released new course about Apache Iceberg. So that's why you see all these videos here. Definitely want to check it out if it's in your. I will post this link into I don't know if it's going to be sent this to LinkedIn, but someone from my team will help to share those links on this new Apache Iceberg course. Now, next thing, like we're doing this a lot of live events. We're doing a lot of the events in the YouTube space, in the live streams, but we're not in lockdowns anymore. We're still doing a lot of in-person events. Tomorrow, literally tomorrow, new events for data streaming engineers happening in San Francisco. It's an in-person event. We still have a few tickets available. You know, we're almost at the capacity. But if you are in San Francisco and you want to join this, this is a great event to be to learn all things data streaming and data engineering specifically. No sales sessions, just only practitioners. You will enjoy this. Unfortunately, I will not be able to be there because I need to travel and I need to also run this event. But hey, now, current London, the biggest data streaming events is coming to London in May. Registration is open. The sessions are announced. It's not the full scheduled yet, but you can find there's a lot of AI talks. There's a lot of data engineering talks. There would be some great presentations. So yours truly will be speaking. I'm excited about this. So registration is open. If you want to attend and you're looking for some interesting discount, write me a DM in LinkedIn or X or Blue Sky, wherever we have you, and I'll find you a some good and compelling reason to join this event if you will be able to travel to London. And also, it says New Orleans, but very soon we will be announcing that the current in San Francisco, which is I'm super excited. Now, we done with these announcements. I see some actions in the comments. Okay, I see the Mark. Welcome from Barcelona. This is great. This is awesome. Great to have you here. We have Kimberly from North Carolina. Welcome. Welcome to live streams. Welcome to Streaming Frontiers. Now, I promise you to bring some very special guests, and here they are. All right, folks. Today we're going to be talking about a very exciting topic with the extremely knowledgeable people who will share. I think this is the pinnacle in data engineering for if you're running Kafka environment for the last couple years. You have to maintain multiple distributed systems to maintain your Kafka cluster. And finally, with the release of Kafka 4, we now don't need to maintain this pesky ZooKeeper. And so that's why I have my friends and colleagues from Confluent, Anjan and Mansi, to talk about how we're going to get rid of ZooKeeper in production clusters. What is automations available? We're going to see some demos here. Folks, welcome to Streaming Frontiers.
Hey, Victor. Thank you. Hello, everyone.
Mansi, can you hear us? Can you see us?
Yeah. Hi, everyone.
Folks, can you briefly explain what you do at Confluent and why the topic of getting rid of ZooKeeper is near and dear to your heart, if I can say that?
Yeah, sure. Probably I will start with my intro. Hello, everyone. I'm Anjan. I'm working in Confluent as a product manager, specifically looking into self-managed Confluent platform and also towards CF enhanceable experience of installing, maintaining, and lifecycle of the product. So today, me and Mansi will be taking you through the journey of migrating from ZooKeeper to KRaft. Before we dive deep into the how part of it, let me talk to you about why part of it, like
Yeah,
why we need to
let's start
migrate
with
to
this.
KRaft.
Before that,
Yeah,
can we get the intro from Mansi and like what she's
Yeah.
yeah,
doing at Confluent?
Yeah. So, hi, all. I'm Mansi. I'm working with Anjan on the engineering team for which manages Confluent for Kubernetes and Confluent Ansible. Yeah.
Okay,
And I'll
great.
be demoing different, yeah. Yeah.
Yeah. So like before we jump in this, let's do. You feel like you're a little bit tense because you feel like it's a webinar. It's not webinar. It's a live stream. It's a podcast. We're gonna chatting. What brought you into this world? Like, have you done this like platform engineering for whole your life, or you just kind of came to Confluent and you find this? Oh, that's going to be my new passion, and this is what I'm going to be doing until the rest of my days. I don't know who wants to answer this one. And John, Mansi, who wants to answer this?
yeah. Maybe I can go first. So, yeah, thanks for this question because so that I can also tell talk to you about my history. So when I started my product journey with when I was with GE Healthcare, that is where I was first introduced into platform engineering. So
Mm-hmm.
I took care of the platform product, which was mostly about data platforms, and that is where first I got into Apache Kafka world.
Mm-hmm.
So that's where my journey started towards
What
Kafka,
year it was?
and
We
it
coming
was
closer to.
2019.
Okay,
It was
2019. We're
2019.
coming closer to like 12 years anniversary of Apache Kafka since it was released, and I just curious like when, at what stage of the people's life it was, introduced in
Yeah,
in
yeah.
in, in their world.
It was still very much Zookeeper when I started. KRaft was making some noise at that point of time, but it was still at pretty early stages, so no one adopted KRaft at that point of time. So I'm talking about 2.x series of Kafka,
Yep,
Apache
great.
Kafka. So yeah, I mean, that's where my journey started, and Kafka has always been part of my life since then till now. And being at Confluent, it's like we are at meat of the problem. So that's how exciting it is being at Confluent and also working on the real world problems, data problems. It excites me every day to be here.
That's awesome. Mansi, what about you?
Yeah. So before Confluent, I was with Flipkart. Flipkart is basically an e-commerce platform which is similar to Amazon, but it is mostly operated in India. So in Flipkart as well, I was part of the data platform which takes care of ingesting all the real-time data from the Flipkart app, be it regarding your orders, be it around your sales of the product. So I used to be part of the team which ingests the data from all these sources and then used to query the data from different data sources and used to provide them to the business analysts for further analysis. So that's where my journey started with data. Post that I joined Confluent, and that's where like the
Oh,
product that we used to use
you're breaking up a little bit, so hopefully it's gonna be better.
Okay.
All right.
Okay.
Can you still hear us, folks in internet? Hopefully we still do streaming and still streaming. Let's jump right in. So we're already 10 minutes in. Who wanted to join already joined. So we're not gonna make people wait because we have a very packed agenda. So John, take it away. I know that you have some slide prepared, and I think these slides will help you to answer this question like why, right? So the what we're doing and why, and Mansi will show how.
Yeah, sure. Thanks, Viktor. I will take over from here. So just for the audience sake, I am not going to bore you with a long presentation. It will still be a hands-on demo. It will still be a pretty much action-oriented demonstration. But before we get into the how, I just want to set the context telling why, right? I hope you're all able to see my screen.
Yeah. I think
So
we still have a screen. We still see these beautiful slides.
Sure. Thank you. So yeah, this is the first slide like which briefly talks about agenda, like why migrate and why now, and timeline of KRaft, different phases of migration, and like typically when we start migration, how does different phases look like, right? And we will also wrap it up with a live migration walkthrough. We can also have an interactive Q&A at the end of it. If at all, if you guys have any questions
hopefully
in
it will
between.
be interactive enough so we can have enough buzz in the chat. So
yeah. Let's dive into it, right? So just to see, right, like how did KRaft evolve and where is ZooKeeper today? So basically, Apache Kafka 4.0 or CP 8.0, which is Confluent Platform 8.0, that is where ZooKeeper has been completely removed from the package. So what does it mean? 7.9 CP or 3.5 Kafka. 7.9 CP, I will talk from CP point of view. 7.9 CP is the last version of Confluent Platform where you can use ZooKeeper and also KRaft. So we call this as a bridge version where customers can be both on ZooKeeper and KRaft at the same time. They can validate their setup, they can run tests, they can do some soak testing, and then completely remove the ZooKeeper nodes. So that's the reason we call it as bridge version. And we see a lot of customers are sitting on this wall at this point of time.
So
and
in
that
this
also
case,
prompts us
with the bridge version, we kind of sort of guarantee that the compatibility between basically major releases. So you will be able to migrate configs, but this is the place where you still have ability to come back, right?
Exactly. Yes. And from 8.x onwards or Apache Kafka 4.x onwards, it is only KRaft. There is no ZooKeeper anymore, right?
Yeah.
So with this context, telling that why it is very important, we'll see like what was the drawbacks in ZooKeeper and how does it overcome with the KRaft, right? So for example, if I simply have to put in words, what is ZooKeeper in Kafka? So if you guys have worked with Kubernetes in the past, or even currently if you're working with Kubernetes, if you know what etcd in Kubernetes is, we generally call it as the brain of Kubernetes. On the same analogy, ZooKeeper was acting like a brain of Kafka because it knew all the information about topics, hackers, anything about metadata. It was working great, right? So there was, because it did survive probably close to a decade in the industry, it
It's
did
it's
pretty
kind of
well.
like it was fine, you know, kind of. It's
Yeah.
not great. I know that there was a lot of sentiment about like why Zookeeper is like needed on the first place. Many Apache and data projects were started with using Zookeeper for storing some metadata,
Yeah,
and including Hadoop, including Apache Pinot, some other places now. And
exactly.
now people
Exactly.
just saying like, okay, we're tired of this because it's an extra infrastructure to maintain. And what
Yeah.
was the problem? Like you folks probably work with the customers. You probably work internally. If for some reasons our like
Yes.
audience don't know
See,
that,
one
like
one major
we're
point,
running,
one major point about
we're running
ZooKeeper.
biggest clusters of Kafka in the world, and
Yeah,
by
yeah,
volume and by number. So that's why kind of like we have some experience.
exactly.
Like, what was the problem? Like, why we need to get rid of this?
Yeah, one fundamental reason is ZooKeeper was never built for Kafka. That means it never understood Kafka. It is like you are having two distributed systems, probably solving one problem statement, end of the day. So when I say two distributed systems, it's like you are maintaining two different life cycles, one for Kafka broker and another life cycle for ZooKeeper. So you need to deploy it, you need to maintain it, you need to version it, you need to upgrade it. So all of these things should happen separately for both the components, right? So, and security posture was different for ZooKeeper, security posture for Kafka is different. So with these kind of differences between ZooKeeper and Kafka, maintaining two systems, as you mentioned, we know that the scale of the system with the customers whom we talk to day in and day out, right? They have hundreds of clusters. Like they have a farm of clusters in their production environment. If something goes wrong, the platform team or an operator team has to run around like looking at where the issues were. So that was one of the major concerns with ZooKeeper.
Great.
Yeah,
So
Victor, you were trying to hint something? Yeah.
no. Like I'm trying to just to share some of the links in social media while we were
Mhm.
talking. So I think one of the problems when we were talking about Zookeeper is that, especially with the bigger cluster, is just too much metadata to send back and forth between
Exactly.
Kafka and Zookeeper.
Yes.
So one of the things, if you have
Yeah.
a large number of partitions and large number of topics, the amount of data that needs to travel between Kafka in order to Kafka to maintain, Kafka still maintains this, like the cluster situation. Kafka
Yes.
knows this, the controller and the knows this, but for persistency, it still needs to be sent to Zookeeper, so Zookeeper will kind of like have this as a storage,
Exactly.
and
Yeah.
that would
So
create excessive kind of like network traffic, and especially when the recovery of those large clusters can take a long time.
oh yeah, that's a major thing, right?
Yeah.
So let's assume one particular cluster which is growing exponentially with the number of partitions. If there is a downtime, the recovery with ZooKeeper will be in minutes, not in seconds. So when I say minutes for production cluster, especially for Kafka, which is always at the hot path for the data transaction, that's a major red flag for any distributed system. So with all of these drawbacks, right? So there was a need for a Kafka's own controller mechanism without depending on an external system. So that is where KRaft was born. So KRaft works on a principle of Raft protocol, which is a consensus protocol. So this is one system. Like when I mean one system, don't go by the number of pods it creates, though it is still a separate pod what it creates as a KRaft controller, but it is still with the Kafka library. So it's the major difference is like if it's with a ZooKeeper, Kafka broker has to ask a different system to understand who my controller is. But in this case, it is all within the system. It knows the quorum, it knows the leader, it knows the system, which is within itself. So that's a major win for Kafka. And the downtime or the reconciliation, what happens before it was in minutes with ZooKeeper, now it happens in seconds because it need not go outside and look out for who the controller is. So it's a major architectural change. So that's the whole point why we have been stressing people or clusters to be moved to KRaft. And we understand this because this is a major architecture change, people hesitate to move to a newer things. All we want to demonstrate today is how easy it is to move to a KRaft version and also be on the same system with both ZooKeeper and KRaft. Test it as long as you like it, as long as you feel comfortable with it, then only move to the KRaft. That's the whole intent of this session.
Great. So let's talk about what is involved to execute this procedure. So we understand why many people got excited. I did myself. I did a few presentations back in the day was when we were talking about the migration. But let's talk about what the components are involved in, what kind of automation we had to build for some of the customers, for some of the people who run this in Kubernetes. We're talking specifically Kubernetes because it gives some tools to run this more efficiently. But in practice, some of the ideas that we will be discussing today can be applicable to other environments. You need to just look to different tools to do your automations and stuff.
Yeah. See, that's a great question, right? So typically, even KRaft migration for the Kafka clients, it doesn't see any blip. I mean, what I mean by that is it doesn't see any downtime because everything is taken care internally. So we do a rolling upgrade. We make sure the system is always working and it is serving to the client's request. So from that point of view, end user shouldn't see a downtime. Though we always see customers take caution, they always do it on the lower environments first, then move to staging, then do production when they see a maintenance window. But what I'm trying to quote is on a sunny day, no one should see any blip even at the client side when the migration is happening. So I will walk you through different phases, basically, like how does it look like? Right. Typically, we have 5 phases within migration itself, and all of these steps are automated. Today, whatever I'm talking about is mostly from the CFK point of view, or which is nothing but Confluent for Kubernetes. So where we have an operator which takes care of this entire automation lifecycle. There are few commands where user has to supply, but mostly operator takes care of migrating from ZooKeeper to KRaft in a seamless manner. So as you see, there are majorly 5 phases, which is a setup phase. Then you have migrate, dual write, and then we probably end up with the complete. So dual write is the most critical step. We will go through like phase by phase. Even when we do live demonstration, we will show how does it look like. So in the setup phase, what happens internally is we prepare the cluster for migration where Kafka brokers role to enable migration mode. So we submit a job, we tell the cluster, prepare for migration. So what it does is it does a bunch or series of pre-checks. It makes sure it is the right IBP version, which is nothing but in broker protocol version. And it makes sure it has ZooKeeper properly configured. It has an endpoint which is configured. It does a kind of housekeeping checks before triggering a migration so that either it has to be 1 or 0. It should not get into an in-between state. That's the whole goal of the setup phase. Once the
question about data. So data is not going to be affected in this case. It's just only the metadata stuff.
Yes, exactly. Yeah. Yeah, there won't be impact for your data. Just to be on the safer side, we do recommend our customers to back up their ZooKeeper metadata just in case if it is required or something happens during the process. Otherwise, even that is not required. As I mentioned, we are not going to touch the actual data. It's only the migration of metadata from one system to another system. That's the migration is about.
Makes sense.
Yeah. So once this setup phase concludes, it's automatically progressed towards a migrate phase. So this is the phase where it copies all metadata from ZooKeeper to KRaft controller. So typically this phase migrates topics, ACLs, and all the internal configurations which is required for a properly functional of entire Zoo for entire Kafka cluster. Right? So this is the migrate phase. So once this migrate phase concludes, this is the most important phase in our migration, which is called dual write phase. So this is the phase where both your ZooKeeper and KRaft will be active. So meaning as a client, when I create a topic or when I update an ACL, the write goes into both the systems, but KRaft would be always acting as a single source of truth.
Mm-hmm.
So why we do this into to both the systems is if customer feels or if an end user feels that they see some discrepancies with KRaft, they can safely roll back to ZooKeeper. Or if they feel, no, okay, this looks great, I want to proceed with the KRaft, they can proceed with the KRaft ahead. But this is the only phase where you could turn back and go back to ZooKeeper. Once you proceed from this step, there is no way turning back. So it has to be KRaft only.
Makes sense. So one of the
Yeah.
questions was just in general when we're talking a little bit about ACLs used to restrict or control access to certain resources within the Kafka and stuff. What we would recommend to do this when we migrated from ZooKeeper to KRaft? Like, what's the mechanism these days?
I mean, from end user point of view, they need not do anything. It would be taken care automatically. So all the ACLs would be migrated to KRaft as well.
So in this
all
case,
of your permissions will be intact.
As long as you're using correct like admin APIs, commands to operate with this, or using command line tools, those will be invoking correct API calls. So it would be transparent for them as well.
Yeah. So as I said, there is absolutely no change for the client how it was working with ZooKeeper. It will continue to work in the same fashion even with the KRaft. So whatever permissions or ACLs you configured for a particular topic, it will still be the same. It will still be it basically there is no change which will happen between the system.
Yeah. From outside world, it would be no change. They will not see any difference.
Exactly. Yeah. So once we overcome this dual write phase, there is a finalize block. What it does is it cleans up all the ZooKeeper nodes. It removes all of your ZooKeeper pods, the PVCs associated with it. Everything will be cleaned up from the system. And from here on, it will only be a KRaft system.
Mm-hmm.
So from Confluent point of view, and also from Apache Kafka point of view, we recommend people to move to KRaft because you will see new features coming in. You will have new bug fixes being added onto the latest versions, and CVE security fixes are always updated onto the latest versions.
Mm-hmm.
So apart from moving away from ZooKeeper, there are multiple benefits moving on to the KRaft. So we recommend any cluster out there in the world with Kafka should be with KRaft moving forward.
Mm-hmm.
And I think our whole intent is to tell that like it's easy to move towards.
It was plenty of time of kind of like a maintain on this like a bridge release and spend a lot of time on the 3x kind of like release, because it was the big work started when the 3x was announced, and work was finalized across multiple different releases, and there's no reason not to use this right now. I know that there's some opinions about this. KRaft is pretty stable. It was validated multiple times through like independent researchers. There's a fairly well documented the scenarios for how the KRaft works. So, folks, let's go for the let's go with the KRaft. So stop living in the past.
Yes. Yeah, one update on the user experience part, like you will see, we will be doing some commands on the screen and all that. But very early, maybe in next 2 to 3 weeks, we are also launching a command line tool or a plugin to navigate through this process. So it will be even more seamless. So if possible, if we have time at the end of it, so we will also try to demonstrate a couple of commands. How does it look like?
Awesome. All right. So it feels like we're ready to kind of like jump into some demo stuff.
Yeah.
Yeah.
So, Mansi, over to you. So we can start
Yeah.
the demo.
Let me know once it's finished. So, okay. So I'll just reiterate few of the things which Anjan has already mentioned. So ZooKeeper has been the metadata backbone of Kafka for years, right? But with KRaft, which is basically uses Kafka's built-in consensus protocol, it will simplify our operations. It will reduce the moving parts, and it is the future that we need to move towards, right? And with Confluent platform, starting 8.0, ZooKeeper has been completely deprecated. That's where we are pushing you to move completely to KRaft mode with the additional features that we have already discussed, right? So what I'll be covering now is a demo of a ZooKeeper-based cluster and how Confluent for Kubernetes can help you migrate the cluster from ZooKeeper to KRaft seamlessly.
Mm-hmm.
So yeah, these are the public docs where we list down various steps which are required to trigger the migration, how you can validate the migration, and how to move forward as well, right? So yeah, so listen. Before proceeding with migration, there are certain requirements that you must cater to be able to complete the migration successfully. One of them is you should have Confluent for Kubernetes product deployed with version 2.9.2 or higher, and Confluent platform with 7.6 or later versions. As earlier described by Anjan as well, 7.9 is the bridge version where we can have both ZooKeeper and KRaft, but post that only KRaft can operate,
Mm-hmm.
right? So as one of the points that we were discussing, right, that how would the ACLs be migrated? So that is also highlighted on this page that ACLs will be auto-migrated from ZooKeeper to KRaft with this migration process. So you,
Mm-hmm.
as a customer, you don't have to worry about that as well. Now, coming to how the migration, how as a customer or as a someone who is interested about doing the migration, right? How you can do the migration is one of the prerequisites is you should have a Confluent platform deployed using Confluent for Kubernetes as the operator. So, as part of this demo, what I have already deployed is a ZooKeeper-based cluster with 3 nodes and Kafka with again with 3 pods, right? So, what I have already deployed is I'll show you the custom resources which I have used to deploy the system.
Mm-hmm.
So it's
So
a
right now
non-secured
we're still running
ZooKeeper-based cluster.
the
Yeah.
latest and greatest version of the
Yes, ZooKeeper. That's
ZooKeeper.
7.9.5.
Mm-hmm.
Yeah. And the init container is basically your init script, which will be triggered before your component comes up. So it's a separate pod itself. It's a separate container within each component. So the version I'm using for that is 3.2. You can get all these informations from our release notes on our website. So it lists down all the 3 versions that you have to use. So the Confluent operator, which I have deployed for this demo is 0.1514.1. And init container, which I have deployed is 3.2.0. But for CP component images, right? Since ZooKeeper was last released with CP 7.9.5, that's where the images for ZooKeeper Kafka is 7.9.5.
Mm-hmm.
Any questions till now?
No, I don't see anything yet, but people complimenting your choice of tooling, and K9S is a great tool for manage with Kubernetes. So,
Thank you. So, yeah, to demonstrate this, right, what I'll do is I'll be following whatever there is in our public docs so that you can also relate post our session as well on how you can go ahead and try this out. So, one of the prerequisites is we have a capability like we earlier discussed as well, right? We have to deploy KRaft and Kafka both on the same IBP version, right? So we have added the latest feature for deriving the IBP version automatically for standard CP images. But in case you are using a custom images, right, then you'll have to add this annotation at your Kafka layer with the correct IBP version mapping, which has been listed as part of this table itself. So let's say you are using a custom CP image. CP is basically Confluent platform here. So let's say you have built your own image on top of CP 7.7, let's say, right? So what you'll have to do is you'll have to add this annotation at the Kafka so that our operator can derive the IBP mapping version automatically and trigger the rule. In this case, it won't be automatic. You will have to explicitly provide the value. But in case of standard images, we can derive this IBP automatically, and then we'll roll out the Kafka with the IBP version mapping.
Mm-hmm.
So what I'll do is, my system is already up with ZooKeeper and Kafka. So I don't need to do step 1 because I'm using standard CP images, which is 7.9.5, which means
And
it
by
would be
default,
mapped
it
to
uses
IBP.
default internal protocol, internal working protocol.
Yes. Yeah. So if it's a standard CP image, we use this same mapping to derive the IBP version. So let's say you are using CP 7.9.1, then your Kafka will be rolled out with IBP 3.9, and same your KRaft will be rolled out with IBP 3.9. Basically, your Kafka and KRaft have to be on the same IBP version to be able to communicate successfully, or to be able to for Kafka to be able to register to the controllers.
So,
So
that is something which operator will take care. So
yeah.
It makes total sense. Yep.
Yeah. So that is your first step. That if it's a go ahead.
Yeah, no, go ahead. We're gonna go to the questions later. Yep.
Sure. So that is the first step before you trigger the migration build, that you have to define the IBP in case it's a custom CP image. Now, what's the next step? Once you have added this annotation, what you have to do is, since our goal is to deploy the KRaft controller, right? So you'll have to define a CR for KRaft controller. And how it might look like is, this is a sample CR of KRaft controller. So the kind here is KRaft controller. Then we have the authorization and certain dependencies for that, right? For this, what I have done is, let me just open my KRaft YAML as well. So this is a
Can you make it a little bit bigger?
This is a non-secure KRaft cluster. For the simplicity, yeah. So this is how my KRaft controller looks like. So
is it just me, or Mansi is breaking up very heavily?
Those are
yeah, we have been breaking up.
All right, and now we lost Mansi. Let's see.
Am I audible now? Or is it still?
Yeah, now it's better.
Okay. Is it better now, Viktor?
Nope, not really. Let me see.
Okay.
We lost your screen, so I need to go and see if I can bring this back real quick. Yeah, we lost your screen. So let me see if I can bring you back.
I share my screen. Yeah.
Here we go.
Yeah. So till what part were you able to connect?
We were talking about the when you were explaining the deployment of KRaft controller, and you have not unsecured the Kafka cluster.
Yeah. So you can see in my that I have added 2 annotations. One is your KRaft migration whole KRC creation, which is being added as true, and other is use log4j1 as true. So use log4j1 is basically to enable the log4j1 library for printing the logs. And this annotation, your KRaft migration whole KRC annotation, it basically is an indicator to your operator that you should not deploy KRaft controller until this annotation has been removed. So, and the same has been added in our docs as well. So this is the step.
So that step is like
This
a safety
basically-
mechanism. Yeah, so basically that step is like a safety mechanism or annotation. So what we are trying to tell is, till we deploy the right thing, don't bring up the controller. So that will happen only after the dual write phase.
Yeah. So I'll cover different subphases as well, where this where we mutate KRaft controller and bring KRaft controller as such up. So what I'll do is I'll deploy this same CR so that we can see what is the output of it.
Okay.
So just a second. Just give me a second. I have the.
Yeah, I hate when when these things happens. Kind of like you need to log in and stuff like that.
It's a Murphy's law.
Yeah.
The question while we're doing this, does KRaft works with a JBot as ZooKeeper did in the past? I don't know if the Anjun wants to.
Yeah.
It does.
Yeah. So that is also covered. CFK supports ZooKeeper migration of the brokers that uses multiple JBots, multiple authorities as well.
Nice. This is great. This is great. All right.
So,
okay, so let's see if we can have a little bit more success now once we already logged in.
Yeah. Yeah. Let me just check.
Yeah, K9S needs to rebounce.
Yeah. Yeah. So let me just completely. Yeah. So if you see, as of now, I don't have any KRaft controllers deployed. What I'll do is I'll apply my YAML with the required configurations that I discussed earlier. So what it will do is it will create my KRaft controller. But if you see here, right, KRaft controller has been set to hold. It has not been deployed yet. And if you see, we are still able to see only Kafka and ZooKeeper.
Mm-hmm.
So that's where we have the protection that unless we are sure of doing certain upgrades around Kafka, we won't bring the KRaft controller up, right?
Mm-hmm.
So let's move further so that we'll get more idea on how we should move further. So what I have done is I'm already at step 2 now, where I have deployed my KRaft controller. What I'll now do is the CR which automates this entire migration workflow from ZooKeeper to KRaft, right? It's called as KRaft migration job. I may refer to it as KMJ later during the session, so highlighting it here. So how KRaft migration job looks like is, it's pretty straightforward. What it will have is, it will have different dependencies where you can define your ZooKeeper endpoints, your KRaft endpoints, or your name and namespace where Kafka, ZooKeeper, and KRaft controller are deployed. In my use case, how it would look like is, let me just minimize this window.
Mm-hmm.
Yeah. So in my use case, how it would look like is, my Kafka is in the same namespace, my ZooKeeper is also in the same namespace, and my KRaft controller is also in the same namespace. So that's the minimum config that you need for deploying this KRaft migration job. Once you have this job, what you can do
is it using kind of like you need to specify a name of custom resource for ZooKeeper, right? So in this case, like Kafka, it's a custom resource Kafka and ZooKeeper custom resource.
Not the name, it's a metadata name.
Mm-hmm.
So once I have this, what I can simply do is I'll start the migration. So what I'll do is I'll just simply apply this YAML. So that's the manual step, only manual step that you have to do till now, right?
Mm-hmm.
You have to create the KRaft migration job. So once you have created the KRaft migration job, right, you will have to monitor the migration of this progress of this job, right? So what we can simply do is, so you can see as of now, the KRaft migration job is in setup phase. There were different phases, right, which Anjan mentioned in the workflow diagram. So the first phase which KRaft migration job goes through is the setup phase. What this phase will do is, it will do different sorts of validation on your existing ZooKeeper and Kafka. Then it will trigger IDP upgrades. So this section is down. So every phase has a certain set of subphases within that, so that at every step, we are aware of what exactly is being done at this stage, right? The IBP version. In step 1, if you recall, I mentioned that in case of custom images, you have to add a particular annotation for the IBP version, right? That annotation is read in case it's at this phase to derive the IBP value. And in case of standard CP images, it will be auto-derived. So to demo it to you, you can clearly see that since I was using CP 7.9.5, IBP version has been automatically derived to 3.9. And after this, there are a few more checks that system does. One of the checks that system do is, once we have derived the IBP, we put a lock on all the 3 resources, ZooKeeper, Kafka, and KRaft. What this lock means is, once this lock is enabled, you are no longer allowed to modify your custom resources so that you don't hamper the migration process in between.
So in this case, this like Kubernetes controller or Kubernetes the application will be kind of like preventing from doing this type of things.
Yes. So you cannot make a change to the system at this point of time.
Yes. And this lock can only be activated when you have webhooks enabled. So with Confluent for Kubernetes, we do have a feature for webhooks. So while deploying the operator itself, you can enable the webhook so that different checks, like we check whether your Kafka is healthy before we actually trigger the migration. Then we check whether your Kafka satisfy the minimum version of CP where migration is supported. Then we see that when we check that your KRaft controller have the annotation for holding the creation. And then the step 6 is triggered where we actually upgrade the IBP of the Kafka brokers. So at this point, and at the phase where the IBP upgrade of the brokers is actually happening.
Mansi, just can you go back to the section where we can also show the sub phase of it? On your K9s.
In the just a second.
So if we carefully see this, right, like now the main phase of this particular activity is set up, and there is also a subphase to it. So which exactly tells what happened, like what activity just happened. So it is like we just did a IBP upgrade complete. So all of this, what she mentioned, is all automated, which is been happening in the background.
Yeah. So
are we in terms of like status? Are we switching to another cluster, or are we gonna wait? Like how are we gonna proceed? Because I remember you mentioned that this process can take some time. Yeah.
So I'll just briefly discuss what are different subphases to give a little more idea. So this derive IBP, I think it's rolling out the last Kafka brokers. So this should be done in around 2 minutes or so. And once your Kafka has been upgraded, the next step is where we muted the KRaft controller. Like there would be some background steps as well where the Kafka cluster ID will be fetched and it would be KRaft cluster as well, right? The major change which you will see in this workflow is at step 10, we'll remove the hold annotation from the KRaft. We provide the Kafka cluster ID that we fetched at 8th stage, and that would be used for bootstrapping the KRaft controller, and will add certain migration configuration as well. So as soon as the lock will be removed, you'll be able to see your KRaft controller pods coming up. So yeah. So at 11th step, your KRaft controller pods will come up and they should be healthy. So this is how, and there would be one more check around the KRaft controller version. But yeah, that is how your setup phase looks like at a high level. So I'll just quickly wait for it to.
We have a question. If you think it's a good time to answer the question, or we have something else, and after that we might have some downtime when we can answer the questions. You tell me.
We can have a question now. Okay, we'll take it later. I can see KRaft controllers are coming up. So now the hold annotation has been removed from the KRaft controller by the Confluent operator that's where the controllers are now coming up. So once your controller comes up, right, and your setup phase is complete, we'll move to something called as migrate phase, where we'll add the migration configurations to Kafka. Then we'll once you add certain configurations to Kafka, the rollout will happen for Kafka so that the configurations are effective. And then Confluent operator itself will monitor your system until you reach the dual write stage, which we mentioned earlier is the phase where your metadata will be written to both ZooKeeper and KRaft. So that's your safe place or your safe zone.
Yeah.
So,
So I just want to reiterate. So far, what we have done is the manual step, only submitting the KMJ job. Nothing else we did. So all we are doing is now monitoring phases and subphases through the system.
and what I can do is,
Because all the heavy lifting has been done by the operator internally. So it is automating every step for user. So the process wise, it's pretty straightforward. Just submit the KMJ job and keep observing it.
Question.
so if you can see now, yeah.
Let's ask the question. So can I deploy KRaft on two different data centers availability zone with no data loss? Means that replication factor is 4. For example, 6 nodes with broker role, unclear leader election is false, and nodes with controller put on 3 data centers. Something like 2.5 data centers with ZooKeeper. Does it make any sense? Let's read this one more time. Can I deploy KRaft into different data centers? Can we deploy KRaft into different data centers? Let's break this down. With no data loss.
You should be.
So when they have replication... go ahead.
No, so what I want to ask is, like, are we talking about a stretch cluster here? So
it
what
looks like it's a stretch cluster because
is,
he mentioned something like 2.5 data centers where you deploy
that's
two
an
zones,
cluster. It's a stretch cluster.
two zones into different the availability zones, and they have a half zone only for ZooKeeper. This is what this is how I'm reading this. This is what something like 2.5 data centers with ZooKeepers. Essentially, it's a stretch cluster across two data zones because we don't need to have another zone for ZooKeeper consensus.
Yeah. See, at a high level, it should be possible, but I will go to that question and probably come back to you on that answer. So it should be possible.
Yes.
Yeah. We do support migration of MRC cluster as well. It's not completely automated yet, but we do have examples covered for that as well in our examples repo, which I'll share it probably towards the end of session, which can help with more details. Yeah. So if we see now, right, I'll just continue on what the current state of my job is. So if you see, right, the current status of my job is that I am at the migrate phase, and what subphase I am at is subphase migrate ensure Kafka role complete. So this is the second subphase of the migrate phase. This step, subphase migrate monitor migration progress, may take some time. So to save some time, what I have done is I already have two different clusters where I'm already at a dual write state. And from this dual write phase, what I'll do is I'll demo both the process. One is moving forward with the KRaft controllers itself. And in case you decide not to move forward, I'll demo how to roll back as well from the dual write phase. So what I'll do is...
So basically, if we don't do anything on this cluster, it will end up in a dual write phase.
Yeah.
Maybe at the end of it, we can come back and take a look at this.
Yeah. Yes. Yeah. So first, what I'll show is, let's say we are all good with how our KRaft controller is up. We have validated that, KRaft controller is healthy and it's working as expected. So what you can do is, I'll follow what our public doc itself says. So we have the inbuilt capability where we watch different Jolokia states to make sure that our migration is in dual write phase. So once we are in dual write phase, I can decide to move to KRaft controller and to make that decision or to complete the migration process, what I have to do is I have to add this annotation called as Craft migration trigger finalized to Craft on the KMJ job CR to true, so that operator is aware that it has to move forward to the Craft controllers. So what I'll do is, and in my KMJ job itself. So this is the only step where you will need a manual intervention still. Like once you have the KMJ job, at the dual write phase is the point where you will have to do the manual intervention because that's your decision point. So what I'll do now is, so that's a different job.
There's some good
So
engagements
Confluent Kafka.
in the comments, and looks like people trying to answer other people's questions.
Sure. If there are any queries, we can take them at the end as well if something is unanswered. So what I've done is I've applied this annotation. You can apply it with from the YAML itself, or you can directly apply it the CR level as well by the kubectl annotate command. So what I've done is I've triggered the finalize. So what you can see is, so we have now moved forward. And what I am currently at is move to Kafka controller only. And the subphase is move to Kafka controller, ensure Kafka role is complete. So let me dive into the subphases. So once you set that annotation right for finalizing the graph, there would again be certain subphases to make sure that everything is up and ZooKeeper dependency has been removed from the Kafka. So first subphase is removing the ZooKeeper dependency from Kafka. Then since we have removed certain configs, your Kafka will be rolled. And then all these roles are safe roles. There won't be any data loss or the downtime. To reiterate that part. Then we'll remove certain config remover from Craft controllers as well. Then your Craft controllers will also be rolled. And once all that is done, your migration will be marked as completed. So this is what it would look like in case you have decided to go forward with the Craft controllers.
So when you
So
look
what
at
I
these
can do is-
subphases, right, you might feel the list is exhaustive. So
Yeah.
how we need to look at those is there's nothing but checkpoints, which
You are
would
done.
easily tell
Yeah.
the end user that where exactly I am in the process. So
I think
that is all
this
it
is
is.
at this point it's not needs it. You know, I don't think the people needs to be scared of this and or kind of thinking about this as a kind of like exhausting list. It's like a diagram that you showed previously. Is basically like every step.
Yeah.
You know, like where you're standing, and this process might take
Yeah.
some time. And I think it's like a very deterministic way. This is where, you know.
Yeah.
It's a good thing that this is like list exists of the steps.
Yeah. So in this case, what has happened is, let me just remove the bot from that. So what I'll do is,
So what are we doing next? Like rolling back to ZooKeeper, is it?
yeah, first I'll wait for this to complete so that we are good here. So you can see that we are now ensuring that Kafka role is complete. This will take some time. What I can meanwhile do is similar to this, what we have is, I have one more cluster where I'm in dual write phase. And what I'll be demoing in that is, so just to show you, make sure that we
This
are
is
in dual
very
write
nice.
phase.
Like I like the status like clearly stated that you know where we're standing, and after that you can have a control, you know where we go.
Yeah, this is the main decision point where you can choose to either go back or go into future or go back in your past. So in this case, I'll show you, let's say due to some reason you saw there are certain gaps in Kafka controller or something is not going right. You can always choose to go back to the ZooKeeper. We have that automation also in place. But like I'll show you what the current process is for the rolling back. And along with that, I'll show you some of the improvements as well, which we are bringing in to ease this process, right? So as of today, for rolling back to ZooKeeper, the way we did for moving to Craft controller, right? we had an annotation for finalizing to KRaft. Similar to that, we have one more annotation called as KRaft migration trigger rollback to ZooKeeper as true, which basically indicates your Confluent operator to roll back to the ZooKeeper mode. And then there are a few more steps where you have to manually go exec into one of the ZooKeeper nodes and remove the Z nodes for controller and the migration. And post that, you have to trigger the node removal process so that your Confluent operator can proceed with the removal of the nodes. But with the coming enhancements, so I already covered one flow from the commands, what the current architecture is. But now with the enhancements that we are coming in with the next patch release that would probably be out in coming months, we are building a plugin CLI for automating this process more. As of today as well, there are a lot of plugins that CLI commands that are supported for fetching different outputs or doing different, like we have different commands for forcing the reconcile, disabling the reconcile, like that, right? Along with that, we are adding one more CLI for KMJ, which is basically a KRaft migration job. And what that CLI would do is, as of now, we are doing a lot of manual steps when we reach the dual write state, right? There are certain substeps that you have to follow. But with this CLI coming in, it would be automated and it will be able to direct you to the next steps, which needs to be taken care once you move forward. So this is still not in production, so I'll demo it. I have that CLI in my local. So what I'll do is,
So
I'll
what we
demo
did
how
now
it.
was
Yeah.
like once we reach the dual rate phase, so the control is driven by annotation. So with one annotation, you can either go to KRaft, with another annotation, you can come back to ZooKeeper. So now what Mansi would show is using the CLI tool, you need not even do any of those things. You could just supply commands through the terminal and it will be taken care of.
So it's an extension for kube control. I still will
Yes.
call it kube control. Sue me, it's not kubectl. A kube
Yeah.
control plugin extension that allows to run
Yes.
Confluent specific commands on the
Exactly.
migrations.
Yes. Yeah.
Yes.
Yeah. This is an existing feature, but we'll be extending it to KRaft migration job as well.
Yeah.
So what I'll do is, I'll first show how this actually looks like so that. Yeah. So what we have this with this CLI is, right, there are different subcommands that the CLI provides. For now, what I have done is I triggered this subcommand called as status, which fetches the status of the KRaft migration job, which has been deployed in the Confluent ZK namespace. So if you clearly see, right, what information it displays is the name of your job, the namespace it has been deployed to, the phase and the subphase the job is currently in, then what's your Kafka cluster ID, your IBP version, which we have derived earlier, and your dependencies as well. And along with the dependencies, it will show the state of your pods as well, whether they are in hold state or are they rolling out or are they being provisioned, right? Along with that, what it would also show you is, right, what are the next steps which are required to be done at your end, or if there are no actions required. In this case, we need to take an action either to move forward to a ZooKeeper mode, to go back to ZooKeeper mode, or to move forward to KRaft mode. I've already demoed moving to KRaft mode in my earlier scenario. In this case, I'll be using this CLI to move backward or
Book
rolling
to
back to the
ZooKeeper mode. Yep.
Yes. So you see, it clearly shows the commands as well here. So what I'll do is I'll simply go ahead and I'll trigger the rollback.
So this will be very easy to execute because you need not jump between our documentation, come back to understand where we are and all that. So the command itself shows you are
I
in
love
this
it.
stage. This is the next command. So this is what you need.
And
I love it.
let's
This
say I
is
trigger
great.
this command, right? Before moving forward, it will always ask for your confirmation if you want to go back. And we always also give a warning that this will roll back the cluster from KRaft to ZooKeeper. I'll press yes, so because I'm consciously moving to ZooKeeper. So now it has triggered the rollback. at this point, what are the next steps for me as a customer who is doing this migration is, one, I have to wait for the rollback to reach a manual Z node cleanup phase. So what this means is we have a subphase. So while rolling back to ZooKeeper, there is a subphase where we earlier used to ask customer to remove the ZooKeeper controller nodes manually with the commands which I shared earlier as well. So once you reach that stage, what you have to do was you had to run these three commands. Basically the two commands, controller and migration. Controller epoch doesn't have to be removed now, just the controller and the migration. These commands required manual intervention and you had to do it manually. But with this CLI, what we can do is this also has been automated. And what you can simply do is you can simply run this command to trigger the ZK node removal as well.
This is very cool.
So let's just wait for it to reach the manual ZK node removal step.
Or you can also run a status command on the terminal, it will show.
Yeah. And let's say I try to run this command before I reach that phase, right? What it would do is, so it has showed an error that migration is not yet waiting for the Z node cleaner. The current phase is this. Wait for rollback to reach to this phase and then retry. So we have that mapping as well.
Accidentally, accidentally, no one can trigger a wrong command with this plugin.
No, this is great. This is great. Like having kind of a dedicated set of commands inside the existing tool, just fantastic. Yeah.
So when I watch this statement, what it says is, we are at subphase rollback to ZooKeeper, ensuring Kafka role is complete. And for me, as in this case, there is no action item. So I don't have any action item. It's just the status that rollback is in progress. Kafka brokers are being reconfigured, no action required. Once you read the subphase manual ZK node removal, then only you will see an action required, which will direct you to run these commands. So let's just wait for it to reach there. Meanwhile, what I'll do is, I'll keep watching the status here so that it's easier. Okay. Yeah. What I'll meanwhile do is, till the time it reaches that state, what I'll do is I'll go back to the KRaft migration job that we triggered as part of this demo in the Confluent start namespace to see what's the status of the job here. Yeah. So if you see here, right, this is the job which we triggered as part of this demo, and it has now reached to the dual write state. And in the message section, you can clearly see what is the action item for you. It says that the KRaft migration workflow is in dual write phase. Cluster is writing the metadata to both KRaft controller as well as the ZooKeeper nodes. And the migration has been paused. To resume the migration, you can either add moving to KRaft controller annotation, or you can add rolling back ZooKeeper annotation for rolling back ZooKeeper. So just a second. My premium is stuck.
Oh, what happened? You want to check the
actually
rollback stage?
Yeah, no.
Okay, it's loading. Yeah.
That screen got stuck. So I'm in the Confluent start namespace. Let's just go back to the ZooKeeper and see what state we are in as of now. So we can see that Kafka is rolling. So that's where the operator is waiting for first the roll to complete, and then only we'll move forward to the other phases of rolling back. So once this roll is complete, we'll reach to step 3, subphase 3, where we'll have to manually remove the ZK nodes, ZK controller nodes. So let's just wait for this to complete. just will complete in no time now, since we are already at the third. Meanwhile, like till it reaches that subphase, do we have any questions that you want to take here, which are related to
Okay, we
this
have
thing?
a question/comments. The person Akshay says you can deploy KRaft-based Kafka cluster stretched across 2 data centers, but you cannot get both. Zero committed data loss across AZDC failure and continuous write availability after that failure at the same time. You must pick which to prioritize. Does it make sense? Is it something that kind of like we have documentation about, like in different modes of deployment?
Yeah, we do have documentation around that especially for MRC clusters. See, the one major thing about MRC cluster is though it is a stretched single Kafka cluster, it is still operated by two different isolated operators from Kubernetes point of view.
Mm-hmm.
So that's one major difference why we cannot achieve a lot of things over there. So that is something which is in our roadmap to handle that part. But coming back to MRC, this migration has to be triggered independently from Kubernetes cluster point of view.
In each of the clusters.
In each of the
In each of the
makes
clusters,
sense. Yeah, there's no coordination between the
No, yeah,
control
because control is with
operators.
different operators.
Yes, different operators.
So to continue, so if you see here, right, I have reached to subphase rollback to ZooKeeper wait for manual node removal from ZK. I know the subphases names are way too long, but what you can focus on is on the message that is displaying that you have to run the commands which were there in the public docs as well. But now for the ease, what we have done is we have integrated them in our CLI tool itself. So what I'll see is, what I can do now is, since you can clearly see the difference, right? Earlier when it was in ensuring Kafka role is complete, it was just saying the status.
Look at
But
that.
as soon
ZooKeeper is
as
still
it
running. Yes.
reaches a, yeah. So what you'll have to do now is you'll have to run this command so that it will remove the controller nodes. So I'm just triggering this command. So before triggering each command, it will prompt me yes or no if you want to continue or not.
Mm-hmm.
I want to continue here. So what I'll do is, you can clearly see at this point, it's removing the controller node. Controller node was deleted. Now it is deleting the migration node. And click yes as well here. And if you remember, in the public docs, there was a step for after which.
Yeah, we need to run the manual commands
after
on the
removing the
ZooKeepers.
nodes. Yep. Yes. To continue after the node removal. So that also is now automated. You just have to prompt your answers. So if you can see, the rollback will Z nodes were removed, cleaned up. Your migration, your rollback has been resumed, and we can monitor the progress as such.
Yeah. So
Can we
basically,
see...
once this plugin is out,
yeah,
we need not follow the documentation also.
Yeah, because it will be self-sufficient and will be guide you through the different steps of overflow. Yeah, this is nice. This is nice. Can we go back into K9S and see like what's the status there?
Yeah. So this is the status of my ZooKeeper one. Let's say we want to go back to the KRaft one, right? Where we have decided to move with the KRaft mode. Let's go to that new space. Yeah. So if you see here, right, the status is now complete. So
this has been
again, it shows you the
for people who are watching this or join us, this we initiated this phase like some time ago, and because we switched to show you progress, we switched to different phases as a part of a different cluster. Now the first migration that we started successfully completed within the less than an hour that we were discussing. This is pretty cool.
Yeah.
This is awesome. This is great. So, folks, let us take a look on Yeah, so let's take a look on this one. So check whatever we did today with the Mansi. Basically, Mansi was doing all the magic, and we were just like hanging out here and being the hype team for her. Check the documentation. Try to run this. Try to understand what is happening there. It is solely depends on a Confluent platform and the things that we built on the Kubernetes operator and stuff like that. It's good if you're using this today. Are there any kind of like recommendations where the people need to move if they kind of self-manage or running open source Kafka? Are there like similar things available somewhere? If you're aware, if you're not, that's totally cool.
No.
All right, so looks like not much in open source. Okay, so I think we are at time. I really appreciate Anjan and Mansi took some time to walk us through this process. It was great. Maybe if there would be some other questions, you can write them under this live stream in LinkedIn or write the comments in YouTube, and we will monitor the comments and getting some feedback. If we want to dig into certain aspects for the future streams, but for now, we're done. Mansi, Anjan, thank you so much for being part of Streaming Frontiers, and we'll see you until the next time. And with this, as a reminder, I'm still Viktor Gamov with Confluent. Oh, maybe I should say already not the Confluent with IBM, but yeah, still Viktor Gamov from Confluent. We happy if you would say subscribe for a Confluent developer YouTube channel where we post all sorts of educational materials and get notified for upcoming live streams in the Streaming Frontiers. And with this, my name is Viktor Gamov, and as always, have a nice day. I'll see you in the streams. Bye-bye.